Dear viewers, welcome to another video in the series of Minitab tutorials. In this video, we are going to understand how can we perform simple linear regression using Minitab. So in one of my previous videos, I have explained about the concept of simple linear regression and also some of the associated concepts like what is called the R squared value, what is called the standard error value. So I have explained all these step by step. So I will share the link of those videos also in the description. So those who are not familiar about the concept of simple linear regression and all the topics associated with it, I would kindly request you to first listen to those videos in the description and then come to this video, because this video will explain how simple linear regression can be performed in Minitab. However, the deeper conceptual explanation of what is simple linear regression is being explained in some of my previous videos. Let's get into this video. As I was explaining in the introduction, for us to understand the concept of simple linear regression, first we need to understand the concept of measuring central tendency, then the concept of what is called measuring dispersion, and then we need to understand the concept of covariance. Covariance helps us to measure the change in two sets of variables together. So basically we say pair of x and y, how x and y are changing together. Is there a relationship in the rate of change of x with respect to rate of change of y, or in other words rate of change of y with respect to rate of change of x. Measuring this is what we call it as covariance. But the problem with covariance is covariance will give you the direction, however it will not give you the strength of the relationship. That's where we move from covariance to correlation, and correlation as a concept goes one step forward and gives you the direction, and it also gives you the strength of relationship. By strength of relationship, what I mean, we will be able to measure what will be the relationship between x and y in an index called correlation coefficient, and that correlation coefficient will tell you as it's getting closer and closer to +1, it's called strong positive correlation. As it gets closer and closer to -1, it's called strong negative correlation. However, again correlation will only tell you the strength of relationship, but it will not tell you to achieve a desired value on my y, what is the level at which I need to maintain my x. And this is where from correlation we are moving one step forward and understanding what is called simple linear regression. By simple linear regression we mean controlling y through a single x. And when we start controlling y through multiple x's, we call it as multiple regression. We will understand or explain what is multiple regression in our upcoming videos. But as of now, we are going to explain how to perform simple linear regression using Minitab. So whatever explanations I gave about concepts, for each of this there is a video that we have already posted. I will share the link of that in the description. So it becomes easy for you to understand these concepts before moving on to this video, where we will talk about how to perform simple linear regression in Minitab. So in this example, I have taken a value of x. For the value of x, there is a corresponding value of y. That means we are collecting x and y as a pair. So as a pair of x and y, we have 6 data points. 6 data points is actually not the right way to do this calculation. We need to have a good enough sample size. However, in order to make you understand, I have taken less number of samples so that the graph becomes easy to visualize. But when you do a regression, try at least you have 30 pairs of x and y before you do regression. Bare minimum, try to have at least 30 samples. Now I click on stats, I click on regression, and here I have something called regression fitted line plot. So here you have 3 types of regression. We are going for simple linear regression, so linear is getting selected. My output variable or my response parameter is my y parameter, observed value of y, and my input parameter is the observed value of x. Now I click on OK, and when I click on OK, I get this kind of a equation. So this is my y equal to mx+c equation. That means my output variable y is equal to c value, which is 4.136 plus m of 1.542x. So what is c? C is nothing but the y intercept when x is equal to 0. When x becomes 0, where this line will intercept to this y axis. So this c, that is y intercept when x is 0, conceptually what does it mean? I have clearly explained in a separate video. I will share the link of that video in the description. Similarly, what does m stands for? M stands for slope of line. That means what is the angle that this line will create with the x-axis, and that angle indirectly will decide what will be the rate of change of y when there is 1 unit change in your x. That is what we call it as m. Then we have the standard error. So standard error is nothing but when you are predicting the value of y by controlling x through this equation, what could be the possible error? You will not be able to predict it exactly the same way. There will be some amount of error. So plus or minus, what could be that error? It could be 1.71 units of your y. If your y is measured in temperature, the difference in your absolute, that is the difference in between your expected value and your observed value, could be 1.71 degree Fahrenheit. That is the meaning. Then adjusted R square does not have relevance when you are dealing with simple linear regression of single x controlling single y. When you are dealing with multiple regression, adjusted R square have a relevance. So at this point of time, R square is important. And what is R square? Your 88.83% of R square means the amount of variability in your response parameter can be explained 88% through this input. That means if this input changes, your output will also change, or in other words, if your x changes, your y will also change. And how much your y is changing, that can be explained if there is 1 unit change in your y. 88.83% of that 1 unit is because of this x, and the remaining is because of the other factors. That is what this R square means. And finally, you have this table. At this point of time, I don't want you to get confused with too many statistical parameters. So this table is also important, but this table talks about how these calculations are being made. So this is analysis of variance for this particular data. Maybe at this point of time, we will pause this. We will not get so deep into it. And finally, you have your fitted line plot. So now if you want to know the value of y, if you change x to 7, you can solve this equation and you can find the value of y. Similarly, if you want to maintain the y at 10, then what you can do, you can solve this equation by replacing the value of y with 10, and by doing a simple algebra way of solving this, you will be able to find the value of x. So as I told in the introduction, simple linear regression is basically a method, or it is a predictive model which helps you to predict the value of y, your response parameter, through your x. Or in other words, it will help you to know what is the level at which you can maintain your x to achieve a desired value on your y. So as I was explaining, friends, in the introduction, simple linear regression, whether it is good enough or it's not a good enough model, whether this model can be believed or it cannot be believed, can be understood by two important parameters, R square and standard error. So standard error need to be as small as possible, and your R square need to be as close to 100%. Then you are working on a good model. So what does this R square means, how it get calculated step by step? What is the standard error means, how it get calculated step by step? That I have clearly explained in a separate video. The link of that video is being shared, so you can listen to that video. I hope this one was helpful. This video was helpful for you to understand how to perform simple linear regression using Minitab. So for more videos on tools and techniques of Minitab and videos on concepts of quality management, continuous improvement, please subscribe and support our channel. Thank you for your time. Thanks for watching this video. See you in another video. Thank you.